Alright, welcome to lesson 1.2 out of variables and patterns. Today we're going to look at how to make coordinate graphs. Now, coordinate graphs are a new kind of graph for most people. Some people might have seen them, most people may have not. So today we're going to make a coordinate graph of the jumping jacks data. The jumping jacks data is from lesson 1.1, so if you just did that, this makes sense. Now, let's jump right in and talk about what a coordinate graph looks like and what a coordinate graph does. So a coordinate graph has some important parts that you can't forget when you're making it. So first of all, it needs a title. You need to tell people what is in the graph. Next up, you need to know what is being graphed. So a variable on the bottom and a variable on the side. Now, we need to tell which variable is which. The bottom one is the independent variable. What it means by independent is it changes the dependent variable. Both are very different. One changes the other one. The dependent variable does not change the independent. Alright, you need to know that this bottom thick line is the x-axis. The side is the y-axis, and both axes count up by a scale of your choice that goes from 0 to whatever number you need to get to. Now, once you have all this, you're ready to graph. It is called a coordinate graph because what you're going to graph are coordinate pairs, which are dots along your graph. So each dot is a coordinate pair which comes from a table or some sort of list of data. So this is your coordinate graph, and this is basically what you need to do every time you make a coordinate graph. So we are going to come back and reference this as we make a coordinate graph for the jumping jacks data. So here is the same table from the jumping jacks experiment on lesson 1.1. We are going to make a coordinate graph of the jumping jacks. First up, we need a title. Don't just call it something random. We're going to use the same exact title that comes from the table. Jumping jacks, which I'll abbreviate JJ, experiment. Now, our variables come from here. Time and number of jumping jacks. So, we got to think about it. Which one changes the other one? Does time change the jumping jacks, or does jumping jacks change time? Well, that last one didn't make much sense. Doing jumping jacks does not change how fast time goes. So time changes the jumping jacks. And here's a hint. Time is always, always, always on the bottom. Now, for our scale, we always start at 0, and then we take a look at the table and see what number we have to get to. Time counts up to 90. If you have to go up to a number that's around 100, count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. We went higher than 90, but that's okay. We just can't go lower than 90. Number of jumping jacks needs to go up to 75. Well, it's close to 100. I'm going to count by tens again. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now, 100 is higher than 75. Once again, if you go higher, that's okay. Now we have to look at our coordinate pairs. The coordinate pairs are pairs of numbers. All of these pairs of numbers where you have a number of time and a number of jumping jacks. So I'm going to start left to right. At 0 seconds, we have done 0 jumping jacks. At 10 seconds, we have done 11 jumping jacks. So 10, 11 is between 20 and 10. You have to estimate. At 20 seconds, we've done 24 jumping jacks, so right about there. At 30 seconds, we have done 34 jumping jacks, so right about there. 40 seconds, 45 jumping jacks, right about there. 50, 54. 60, 62. 70, 62, 80, 68, and 90, 75. Now, one last thing. Connect the dots with line segments, and then you have a full-blown coordinate graph. Now, let's answer a question about this data. What is the relationship between the time and the number of jumping jacks? Now, a relationship in math is how one variable changes the other. And so I have a little fill in the blanks. As the blank went up, the blank went up or down. So as the independent variable, which is here, as time went up, the dependent variable, which is here, jumping jacks, went up or down. Well, let's take a look. In our table, as time got higher, jumping jacks got higher. In our graph, as time got higher, jumping jacks got higher. So as time went up, the jumping jacks went up. Alright, let's move on to our practice problems. We are basically going to do the same kind of thing again, make a coordinate graph, answer some questions. So, practice problems. A convenience store has been keeping track of its popcorn sales since opening. We are going to make a coordinate graph of the table below. Now, first thing for the coordinate graph, once again, is we need the title. We are going to take the title from the table, popcorn sales. Now, our variables, once again, we have time and we have the bags sold. Well, time is always independent. Time always goes on the bottom. So time and bags. Both the scales are going to start at 0 and then count up from there. Time, we have to get all the way up to 13. Now, it's higher than 10, so we can't count by ones. If I count by ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'm only going to get to 10. It's not high enough. I can't go less. So I'm going to count by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Count by twos got me there, and that works. Now, bags, I need to go all the way up to 92. So I'm going to count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Works for me. Now let's graph. We have 0 hours, 0 bags sold, right there. 1 hour, 3 bags sold. So 1 hour is between here, 3 is between here. Make your best guess. It's going to be somewhere around here. If you accidentally put the dot up there, that's not okay. It needs to be down in the correct area. 2 hours, 15 bags. 2 hours, 15. 3, 20. 3, 20. 4, 26. 4, 26. 5, 30. 5, 30. 6, 45. 6, 45, 7, 58, 7, 58, 8, 58, 8, 58, 9, 62, 9, 62, 10, 74, 10, 74, 11, 83, 11, 83, 12, 88, 12, 88, 13, 92, 1392. All my coordinate pairs are on the graph. Now I'm going to connect them with some lines. Now let's answer some questions about it. Which variable did you put on the x-axis and why? Well, if you remember what I said when we wrote time down here, time is the independent because time cannot be changed. So time is on the bottom because time is always independent. Time is on the bottom because time is always independent. Now, describe how the speed at which the popcorn bag sold changed during the day. If you remember from lesson 1.1, the speed is what's being added every time. So let's take a look at our table and see what's being added. Plus 3, plus 12, plus 5, 6, 4, 15, 13, 0, 4, not 8, that's a mistake, 12, 9, 5, 4. Start out low, go high, low, high, low, high, low, low, higher, higher, lower, lower, lower. Looks pretty darn random to me, so that's what I'm going to say. The speed went up and down randomly during the day. Don't have to say why, we don't know why. It went up and down randomly during the day. Number 4. Between which hours did the store sell the most popcorn, and how do you know? Let's take a look. 3 bags, 12 is pretty high, 5, 6, 4, 15 is higher, 13, 0, 4, 12, 9, 5, 4. 15 bags was the most sold in an hour, so between hours 5 and 6. So, between hours 5 and 6, because 15 were sold. Now, between which hours did the store sell the least popcorn, and how do you know? So instead of looking for the highest number, we'll look for the lowest number. Well, in all these numbers, we have a 0, which is the lowest, between 7 and 8. So, between hours 7 and 8, because 0 were sold. Now, let's look at the graph between hours 7 and 8. I just want to point out the graph is flat when nothing is added. So if nothing's happening, the graph is flat. Alright, let's go back through the worksheet, make sure we've answered everything we need to answer. Okay, nothing there. The coordinate graph, make sure you hang on to this because this is very, very handy in reminding you what needs to go inside a graph. We graphed our jumping jacks experiment. We answered a question about the relationship. We graphed the popcorn sales, and then we answered the 4 questions about that. Next up is going to be lesson 1.3 in variables and patterns still.